Okay, so here we're going to talk about how to find the rate of change from from the graph of the function. So what you're going to do, if you have a graph, you're going to locate 2 points that you can clearly read. Okay, coordinates are very clear, so preferably on the intersection of two lines so that you can read your graph really well. And you identify your x and y for coordinates for point 1, and then you're going to identify your x and y coordinates for point 2. So, and we said that the slope or the rate of change is change in y divided by change in x. How do you calculate the change in y? So change in y is how much the function went up or down when you moved from one point to another. So it's only the vertical change is your delta y. Now, delta x is your horizontal change. So when you moved from uh, point 1 to point 2, how much horizontal change went on? So we're breaking this total change into the vertical change versus the horizontal change. So that's what rate of change really is. It's how much vertical change over horizontal change. Um, and that's a very important definition actually for the future, especially for your calculus class. What is rate of change of the function? So it's a change in y over change in x, vertical versus horizontal. So how do you find the vertical change mathematically if you know uh, the point's coordinates? Well, that's the y coordinate of the first point minus the y coordinate of the second point, or vice versa. You have to be, it doesn't matter which point you call point 1 and which point you call point 2, as long as you're consistent here. Okay, so it's your y coordinate of point 2 minus y coordinate of point 1, and the horizontal change is x coordinate of point 2 minus x coordinate of point 1. And here it is. Does it look familiar? Yes, so I hope you said yes, and that's basically how you calculate the slope of a line. All right, this is your slope of the line formula. All right, let's apply it. So here's an example. It says if f of x is a linear function and points 2, 3, -2, and 8, and 1 are points on the line, find the slope. Is this function increasing or decreasing? Okay, so they didn't give us equation, they just gave us 2 points, and they told us that it's a linear function. That's important. That's important information. I'm going to call this 3x1 and -2y1. So that's where you need to be consistent. If it's point 1, you label everything, both coordinates 1, with a subscript 1. And this is going to be my x2 and y2. Okay, so for m, it's delta y over delta x. And how do I find delta y? It's y2 minus y1 over, and for delta x, it's x2 minus x1, right? So that's the formula. Let's plug in those values. Y2 was 1, and y1 was -2. So minus a -2. Guys, please put 2 negatives here, okay? That's a common mistake that I see, is that students, once they put a minus, they don't put that minus again. So there's 2 minuses here. There's one from the formula, and one denotes a negative y value. So there has to be 2 negatives there. Okay, for x2 we have 8, and for x1 we have 3. So yeah, there are two minuses, one on the top and one on the bottom from the formula. And then if the value is a negative value, you denote it with another minus. Okay, so this becomes 1 plus 2, and this is 8 minus 3, so we have 3 over 5. So slope for this line is 3 over 5. Is the line increasing or decreasing? What do you think? I hope you answered that. All right. A couple more examples before we move on to the next topic. It says if f of x is a linear function and 2, 3, and 0, 4 are points on the line, find the slope. Is this function increasing or decreasing? And I want you to try this problem on your own. I'm going to pause here. Oh, well, you pause the video here. And I assume that you did that, and we're going to move forward to the last example in this video. And that's basically how do we apply it. So here it says finding the population change from linear function. The population of a city increased from 23,400 to 27,800 between
2008 and 2012.
Find the change of population per year if we assume the change was constant from 2008 and 2012. Okay, so here's an important information. The change was constant. Okay, so this gives us permission to use linear. It tells us that it's a linear function. So we're going to use the linear model because there are all kinds of models out there. So linear model is f of x equals mx plus b. So that's our model. We're using linear function to solve this problem. So let's identify the input and the output. So the input is in the output. We have for the input, well, first of all, we're going to decide what depends on what, right? Which is dependent variable, which is independent variable. Does our population depend on the year, or does the year comes first? And then the population depends on that year. So if the year comes first, I hope that's what you answered, that's our input. So the input is the year. And then the population is the population is our output. Okay, so and let's create a table of values. We're only given 2 instances, right? We're given the for the year 2008, the population value was 23,400. That's our first pair of points, and then a pair of values. And then the second pair was in the second instance was in 2012, and the population there was 27,800. So they gave us 2 pairs of values. So those are basically your 2 points, your 2 x1, xy points. And I mean, this is x1, this is x2. And now this is y1 and this is y2. Okay, so to find the rate of change, remember it's the same as slope, a rate of change, but it's more mathy way of talking about it, delta y over delta x, where delta y is y2 minus y1. So 27,800 minus 23,400 divided by x2 minus x1. So 2012 minus 2008. Okay, let's calculate that rate of change. Okay, and I got 4,400 over 4. Let's put units to it. So the y is our population. So what are the units? Persons. And on the bottom, the input was in years. So, and let's go ahead and divide 4,400 by 4. That's going to be 1,100 persons per year. So that's our rate of change. So when you're finalizing your rate of change, always divide out your values. Even if you get a decimal here, that's okay. The rate of change is always over 1. So we don't want to keep it as a fraction. Now the question is population increasing or decreasing? And since we got a positive value, so we're gonna have we're gonna say that the population is growing, or increasing. And if we want to be really fancy, and I don't have room here to write it down, but you would say it's growing at the rate of 1,100% per year. All right, and this is it for this video. Please go to the next video. Oh, not yet. Haha. I want you to try this problem by yourself. Show closer for you. So it reads, the population of a small town increased from 1,442 to 1,868 between the years of 2009 and 2012. Find the change of population per year. If we assume the change was constant from 2009 to 2012. So find that rate of change.